In this video, let's study force of friction between solid surfaces. Consider a block A placed on a surface. According to Newton's third law, the block and the table apply normal forces on each other. Here, this normal force is the contact force. Suppose I try to push the block, but the block doesn't move. Now the contact force changes and can be given by F, which can be resolved into vertical component, the normal force, and horizontal component. This horizontal component is the frictional force, which opposes my push and keeps the block at rest. Now if the block A is placed on a cart and the cart moves with a velocity such that the block doesn't slide back and fall. In this case, frictional force is responsible for the motion of the block, contrary to the above case where it was opposing the motion of the block. Thus, frictional force opposes the relative motion of the surfaces in contact. This is contrary to the misconception that friction always opposes motion. Imagine a person wants to move a heavy box in his room. He starts pushing it, but the box does not move. As the box is at rest, the resultant force on the box is zero. In this case, the frictional force between the floor and the box opposes the applied force. This is static friction. Now the person gradually increases his force, and accordingly the friction also increases, and the box stays at rest until a point when the friction can no longer oppose the applied force and the box starts moving. This maximum force of friction just before the box starts moving is called limiting friction. The magnitude of this limiting force is proportional to the normal contact force between the box and the floor. This maximum force can be given by the equation maximum force is equal to mu s times n, where mu s is the coefficient of static friction and n is the normal. The limiting friction is dependent upon the nature and material of surfaces and independent of the area of the surface in contact. Once the force exceeds the limiting friction, the box starts sliding on the floor. Now the friction acting on the box is kinetic friction, and its direction is opposite to the velocity of the box with respect to the floor. Keep in mind that the box also exerts friction on the floor of same magnitude, but in opposite direction. The magnitude of kinetic friction is proportional to the normal force between the two bodies. This force can be given by this equation. Kinetic friction Fk is equal to mu k times n, where mu k is the coefficient of kinetic friction and n is the normal. The kinetic friction is dependent upon the nature and material of the surfaces and independent of the area of the surface in contact. The friction involved in case of rotational motion of a circular object on a floor where the object does not slide is called rolling friction. The surfaces at contact do not rub each other, and the point of contact between the object and the surface always has zero velocity. The rolling friction is quite small compared to kinetic friction, and that is why they say that discovery of wheel is so important in the history of humanity.